What are you talking about? Oh,
When are you guys doing your degree?
oh, some, yeah, December, yeah.
What talking?
Civil liberties.
What? Give me like an example.
No, it's just civil liberties in general. We each choose the different things that we debate. Like it could be gun rights, it could be freedom of speech.
Oh, environmental.
They changed it.
Oh, for debates.
Last year they didn't have classes.
Or
Take that over.
Civil responsibility.
You get to choose, yeah. So like, oh, it's not.
Last year they didn't have environmental.
Go against.
No, last year.
You're not. Oh, fuck. I have no idea.
There's a national topic and y'all bought it. They would get that. Yeah.
Most people.
Most people.
Yeah.
And then Jackson is the most annoying debater. He doesn't back it up by facts. He just talks very loud and very
Yeah, our teachers just like play.
and very passionate.
That's why last year.
Yeah, wasn't that what they're He was kind of
No
like.
limitation, no application. And just.
Yeah, I wanted
We actually.
I love you.
We let it go 7 minutes over.
They don't like. I don't.
Should be on.
I love you would have.
You win some, you lose.
I don't know.
Oh, yeah.
Yeah, definitely gonna be, we take save your entire.
The thing that we need to.
Yeah, went to us, I went to another country and saw how they have it. So I actually, it's just with that number, then I would just like a
Ron.
I wanted to just draw a dream. I wanted to write this.
Oh, yeah, I literally said I was gonna put it up and I.
Daniel, are you going on a mission?
Wow, there's.
Oh, yeah. You definitely.
Everybody's doing.
You don't like the missions.
He's gonna be a missionary.
Like you build a host.
Dude, I don't like my head. I put on hierarchy, I got pneumonia, and we're in.
Source control.
Yeah.
Squad.
Yeah.
Lucky soul.
What?
Told me that week, I was
I
crazy.
have to.
Yeah, it's just like the mission.
Funny game.
Then Daniel, are you gonna go on any mission?
Fish Krakow.
Davey. I never.
Are you gonna be
How
how
many times
I had 80 of those Fish Krakow.
All right, let's just go over the calendar real quick here.
Sometimes.
What are you yet?
So we're starting our second to last unit of as far as AB content goes. So this unit is differential equations and slope fields. I think for the most part, solving differential equations will feel familiar to us because we're just taking the antiderivative of both sides of the equation. The problems may feel a little bit longer, but we're just going through our process of applying our antiderivative rule, whether it's power rule or use substitution, and then trying to solve for C and trying to get our equation up from general to a specific solution. So a lot of this process should feel familiar. It's just that it feels extended because we're working on both sides of the equation now. Slope fields will feel a little new. We haven't seen that before, but it's not too difficult. So we should be able to get through all of this unit's topic by Friday. And then we can start our quiz review next week. So we'll have quiz review Monday and Wednesday, no school on Tuesday. Thursday, we'll see. Maybe I start notes. Maybe we'll have another day of review. I'm not sure yet, but we do want to get in the quiz by next Friday. And the hope is that we can get in all of our new content. Also a quiz, our final unit quiz or our final new topic quiz before Thanksgiving break. And then hopefully after Thanksgiving break, we can just focus on AB, FRQ contents, just being able to understand what type of FRQs we can expect as far as AB content goes. So it's kind of like a little bit of AP exam review at the end of the semester. So I said I was going to have a FRQ test, but I may push this off till after Thanksgiving break. All right, so let's go to page 1. Separation of variable. When we want to find the antiderivative of dy dx, in this case, equals 2x over y, it's easier to identify what needs to happen if we can group the variables together. So we want to rearrange the equation with y and dy on the left side, and then x and dx on the right side. Now, your dependent doesn't have to be on the left, your independent doesn't have to be on the right. It's just, it gives us, I like to do that. It kind of gives us a structure to follow. So I'm always going to do that. Always going to try to group my dependent, anything related to my dependent variable on the left side, anything related to my independent variable x on the right side. So my first step is I like to always cross multiply. Now, when I do cross product, it's really just so that I'm not having to deal with a lot of fractions. It's easier to see where things may have to go. So I'm always going to start off my process that way. Okay. Just understand that we may not get full separation variables when we do that, but at least we don't have to stare at a bunch of fractions. It's easier to know what our next step will be. So. Now, once I do cross multiplying, my variables are already together, so that's nice. The y's and dy's are together, the x's and dx's are together. The important thing that for us to understand is that your dy and dx's are your anchor variables or your anchor notations. These have to be in the numerator. When we begin our antiderivative process, these have to be in the numerator. Sometimes your x's and y's land in the denominator, and that's okay. Okay, we have rules that can handle that, but we should need to make sure that our dy dx's are landing in the numerator. So everything is lined up nicely. Our dy dx's are in the right place. Our y's and x's are nicely separated. Y's are together, x's are together. We can now move into our antiderivative step. So we're essentially trying to move this derivative level up to a function level. We're starting out pretty easy here. Both sides just require power rule. Y becomes what? What's the antiderivative of y? Power rule, right? So y to the second over 2 plus c, right, equals 2x squared over 2 plus c. The 2's cancel out. I have y squared over 2 is equal to x squared. I'm going to merge the c's together. So here's the big picture is that when we're dealing with c's, we're always just going to have it show up just on the right side. Technically, it's showing up on the left side as well, but we're always going to merge the constants together and just put it all together on the right side. Just show up once. We can do a little bit of cleanup here. We're not going to do much. If I multiply everything through by 2, I can at least get this down to y squared. So y squared is equal to 2x squared plus c. Technically, it's plus 2c, but we know any coefficient times a constant is still a constant. And eventually, in future problems, we're going to have to figure out what the c value is, and then we're also going to figure out how to get down to the y. But right now, we'll leave it in this form. Oh, I just wanted to get that y squared over 2 to be a little bit further cleaned up, but it's really not much of a difference. Okay, example 2. First things first, we want to separate our variables. I'm always going to cross multiply first. Now, with differential equations, the parentheses are usually there to help you. They're not there to throw you off. Sometimes with antiderivative problems, we may see, oh, we need to expand this out, or it may look like a used substitution problem when it's really not. But with with differential equations, typically the parentheses are there to help you so that you know what needs to stay separate. So just keep that in mind, that typically the parentheses are here to help and not to distract. All right, so first I'm gonna set up so I can just try to begin my cross multiplying process. Again, the only thing this does for me is it gets my dy dx's lined up in the right spots, but it doesn't guarantee separation of variables. But I am making progress in the sense that at least I have my dy and dx's lined up. So I'm always going to cross multiply in a way where my dy is going to land on the left side and my dx is landing on the right. That's always my first priority. I want to get these locked in. These are going to be my anchor variables. And then if I want to move things, I'll move things around it. I don't want to move these anymore. Now we take a look back and say, or we take a step back and say, do we have full separation of variables? Do we have x's together? Do we have y's together? No. So what needs to move? Good. So this helps us remind this parentheses is there to help us that, oh, I want to move the y. I got to move the 1 plus y along with it. Okay. So where's going to end up on the left side? In the denominator. And again, it's okay to have y's in the denominator. Sometimes I see students, they get that y in the denominator and they feel, wait, it's out of place. So they want to move it up to the top and then it just throws off their problem. So it's okay if your x's and y's land in the denominator. We have rules that can handle them in the denominator. So here's my rewritten form. My y's are together now. My x's are together now. I'm going to say 1 over y plus 1 or 1 plus y dy is equal to integral of x dx. Okay. The right side is power rule, but the left side is a little bit of what? Yeah, a little bit of u substitution. But if you can see that this is really just 1 over u du, that's fine. You can do this without going through u substitution, but I'm going to do it. Anyways, I want to just show all the steps, but sometimes I will say this, for simpler u substitution problems, if you skip the step and jump and bypass u substitution, I'm okay with that. Okay, you don't have to show every step if you're comfortable skipping past u substitution. Same thing, AP exams, they don't have to see all your steps. But I am showing my steps in this problem. So this ends up being just 1 over u du, which is natural log absolute value of u, which if I bring back the original variable, it'll be ending up natural log absolute value of y plus 1. All right, so I have that left side cleaned up. The right side will just be what? X squared over 2 plus c. Okay, so here's my, I'm basically done with the calculus. I have everything up to the function level. Now it's just a matter of how can I get y by itself? So let's pause for a second and make sure we're okay up to this point. We took the antiderivative. We're done with the calculus. The only thing left to do is solving for y. And we'll leave the c alone. They don't give us any order pairs for it to solve for c, but we can solve for y. Any questions up at this point? Okay. So to solve for y, we got to undo this natural log. So the way we can undo natural log is we can involve the inverse. We know e and natural log have a way of canceling each other out. So I'm going to do this. I'm going to raise both sides with e as the base in the hopes of kind of undoing and canceling that natural log out. So this turns into absolute value of y plus 1. Now I'm going to use a exponent property here on the left side, on the right side. If I have a to the m plus n, I can expand that into a to the m times a to the n. So I do want to separate them as the product of two terms for the next step. So this is my base. These are my exponents added together. I'm going to say e to the x squared over 2 times e to the c. Right. Are we okay with applying that property? Now, e to the x squared over a 2 is just some variable expression. E is a number, c is a number. So what do you think we can just call e to the c? Just c, yeah. So e to the c is just some constant, but now it's being multiplied. So it's e to the x squared over 2 times a big C here. I like to have my my coefficients in front of my variable, so I'm going to pull that C out in front. Oh, so yeah. So what I'm doing is I'm exponentiating both sides. I'm forcing both sides to live up as an exponent, and I'm causing both sides with e as the base. Got it. Yeah. So I'm doing that to force that e in natural log to have that to build that relationship, so I can remove them from the problem. Yeah. So there's one more thing I got to do. I got to drop the absolute value. The absolute value represents plus or minus. So I'm going to drop the absolute value and say y plus 1 equals plus or minus ce to the x squared over 2. Are we good with this step? Now, c represents constants, but c represents both what? Positive and negative. So the plus and minus just gets absorbed into that c. So I can just drop that plus and minus and just say ce to the x squared over 2. And finally, I'm going to subtract 1 to get y by itself. Now, the 1 doesn't get absorbed into the c because the c is being multiplied, and that minus 1 is being added or subtracted. So we can't just let that 1 get sucked into that c. So we do need to have that 1 separate. So really, this whole section, we're just trying to take the antiderivative. We're trying to get our derivative function up to the our derivative equation up to the function level, but these problems a lot of times require work on both sides to achieve that. All right, example 3. All right, find the general solution for 2x plus 3y, y prime equals 0. Then find the particular solution if the solution passes through the point 1, negative 2. So whenever they give us order pair, that's going to help us solve for our c value, where before we didn't have enough information to solve for c. Anytime we see y prime, I'm going to rewrite it as dy over dx. It just allows me to have more descriptive variables. I like to have dy dx's so I can line them up and put them where they need to go. So I'm going to rewrite y prime as dy dx. And I'm going to go through the steps of working towards cross multiplying, because I do want to get my dy and dx's lined up in the right places. Yeah, that's always going to be my first priority. I want to get those anchor variables in place, and then I can decide, okay, do I have my x's and y's on the correct side? All right, cross multiply. I'm going to always cross multiply in a way where my dy will be on the left side and my dx on the right side. So I'm doing that just to get these dy dx's in the right spots. And now I take a step back and ask, do I have full separation? Are the x's together and are the y's together? Yes, so it's already together. Again, cross multiplying doesn't guarantee that your variables will be separated, but in this case, it's already separated, so we don't have to do any more work. Now, having said that, I like to make my left side as minimal as possible. So if something doesn't have to be on the left side, I like to go ahead and move it to the right side because eventually I'm gonna have to solve for y anyway. So I just want to remove any clutter on the left side. The earlier I can do it, the less work will be in the future. Now, if you want to leave the 3 on the left side, that's fine. But eventually you will have to move it over to the right side. So I'm going to go ahead and just get that left side as bare minimum as possible. I only want what I absolutely need on the left side. That's my preference. Right? So again, not required because technically we have full separation. I'm just doing some cleanup before I move into my next step. All right, so full separation. Now I do want to take the antiderivative to get these derivative levels up to my function level. Okay, power rule. Okay, so I want to make sure that we understand if we're up to this stage, we're done with the calculus. Okay, so now it's just a matter of cleanup in terms of trying to solve for y and trying to solve for c. So as far as AP exam goes, if you can get to this stage, you pretty much earned the majority of your points because you've shown all your calculus steps. It's just the matter of, can you solve for y? Can you solve for c? I do want to point out something about the AP exam. Sometimes, though, the algebra required to get from here to the end can be a little tedious. But just keep in mind that, if this was worth like 4 or 5 points on the AP exam, working from here to the end is probably only worth another 1 point. So, on the AP exam, you're always trying to decide, is it worth the trouble to spend all this time when there's other things that could be more pressing? Okay, so just keep that in mind that if your algebra process feels like, oh, this is going to take too long, is it worth spending 5-10 minutes on 1 point when I should be doing something else? So yeah, just keep that in mind that, at this stage, you've pretty much earned a good chunk of your points. This is not a difficult one to get to the end, but sometimes there are problems that algebraically is a little bit much in terms of the work involved just to earn that 1 point. There's also, to get to the end, everyone may take a different step. Everyone may have a different way of getting to the end, and that's okay. All right. So just keep in mind that I may have a way of solving for C that may be earlier than what you would expect. And also, because we're solving C values at a different point, all of us may be solving C at a different point in the problem. We may get different C values halfway through, but in the end, we should agree. Okay, so if I'm getting a C value that's different than yours, we may still be, both of us could still be correct. It's just, when we get to the end, then we can kind of see, okay, whether we're on the same page or not. So sometimes I solve for C first. Sometimes I solve for Y first, just depending on the problem. In this case here, I'm going to do a little bit of cleanup, and so I can solve for my C value before my square root sets in. But I feel like I can do a little bit of cleanup on the left side just by multiplying a 2 through. And the reason that I want to solve for C at this stage is because if I solve for y first, then I got to deal with the square root, and the C value may just feel a little bit messier down the road. So, but the big picture is once you get to this equation, then it's up to you. You can solve for y first, you can solve for C first, you can clean up a little bit, then solve for C, and then solve for y. So, there's no real structure after this. As long as you're following your algebraic rules, you can really do anything you want. So at this stage, I find this is a relatively clean equation. So I'm going to take this advantage of this and just solve for C. So 1 will plug in for x, -2 will plug in for y. All right, so once I solve for C, I'm going to go ahead and update where I initially made my substitutions. So in this case, I decided to solve for C first. And now to solve for y, I can just take the what? Square root. Now, when you take the square root, what's going to show up? Plus or minus. But these are actually showing two functions here. But we only want the function that's going to pass through this point 1, -2. So let me show the two options here. You got the positive square root version, or you have the negative square root version. Now, which function will allow me to plug a 1 in and get a -2 in return? The negative, right? This is the only one that's going to give me that option because this is going to give me a positive value. So if you're down to a square root and you're deciding between plus or minus, look at the y value. If the y value is positive, you want to choose the positive square root. If your y value is negative, you want to choose the negative square root. If you forget that rule, then it's okay. Just plug 1 in and see which one will give you the y value you're looking for. So the ones that we just did are a little bit easier because there's really just power rule. There's no U substitution involved. But if there's U substitution involved, it kind of extends the problem. There's a little bit more to it, but it still should feel familiar. Okay, next page. So we have y prime equals 6 cosine pi x. Find a particular solution. We have an order pair 1, 2. I'm going to go ahead and rewrite my y prime as dy dx. Cross multiply, because I want my dy dx's in the right places. Again, separation of variables is not guaranteed after you cross multiply, but at the very least, you will have your dy dx's in their right slots. In this case, do we have full separation? Yes. Left side is power rule, but the right side, we gotta do a little bit of what? U substitution. Your U value being pi x. Yep. So I'm gonna set up. I'm gonna spend time working on that right side first. I know the left side is just power rule. There's going to be a leftover 1 over pi that's going to show up. So it's going to be 6 over pi. That's going to be our leftover coefficient plus antiderivative of cosine. That's, that's derivative, right? Antiderivative of cosine is going to give us positive sign, right? We know sine's derivative is cosine, so it makes sense that cosine's antiderivative will bring us back to positive sign. Okay, so y becomes y squared over 2, cosine becomes sine. We bring back our x, coefficient stays. So here's my everything up at the function level. So this turns into this. Again, you may be solving for C and for Y at different stages than me, and that's perfectly fine. I'm just doing a little bit of both. I want to clean up that left side first, get that y squared, and then I want to solve for C because I want to get it in before the square root comes in. Okay, sine of pi is just what? 0. Once you solve for C, make sure you insert it back where you initially started making that substitution. Again, this is going to end up giving me a square root, which will cause me to have to decide between two solutions. Again, how do we decide between a plus or minus square root?
See which would give the positive 1 or
Uh,
positive 2.
Yeah, look at the y value. Yeah, the y value is positive. The only way I'm getting a positive y value with 1 inserted in is if there's no negative in front. So it's positive square root. Okay, I want to make sure I have enough time to do a little bit of review of your FRQ. So if you can turn to page 7 from your test review.
Yeah, I'm not in the net.
All right, let's read this problem here. Hot water is dripping through a coffee maker, filling a large cup with coffee. The rate that water in the cup is changing is given by differential equation C of t, which is measured in where t is measured in minutes. Selected values of C of t measured in ounces per minute are given in the table above. So let me talk about what's happening here. So at 0 minutes, no water has entered into the coffee maker. 1 minute in, the rate is 5.1 ounces per minute. 3 minutes in, the rate slows down a little bit, 4.2 ounces per minute. 3.3, it slows down 1.2 and picks up slightly at 2.3. Right. So these are all rates, right? So interpret the meaning of C prime of 6 and indicate the units of measure. So if C is in terms of ounces per minute, then C prime would be what? What unit would that be? Yeah, ounces per minute squared, right? Ounces per minute. So it says interpret, but I also want us to approximate. C prime of 6. So how do we find, what would you do to approximate C prime of 6? We can't find the derivative, right? So the next best thing is what? Slope, right? So what do we need if we want to find slope? 2 points, right? Which 2 points would you choose?
6 and 9.
Yeah, 6 and 9, 3 and 6. You can even go with 3 and 9. Okay. I'm going to go with 6 and 9. Oh, sorry, I didn't ask for approximating. Sorry. So I'm just merging A and B together here. So how can we interpret what's negative 0.7 ounces per minute squared mean in the context of this problem? So anytime we want to talk about, basically this is rate of a rate, right? So if you want to say rate of a rate, well, first off, we don't want to say anything. This is kind of like second derivative level, right? But we don't want to use the word acceleration because it doesn't quite fit the context of this problem. We also don't want to say rate of a rate because it's not specific enough. You want to say words like the rate is increasing or the rate is decreasing. That's the wording that that will earn us points on the AP exam, right? So we want to say that the rate of the water added to the cup is changing, and the rate that the water is added to the cup is going to be decreasing by this value. So when you say the rate is decreasing, you're basically involving that second derivative level, right? Because rate is at the derivative level and the decreasing is a rate of a rate. But we want to use these, we want to combine these words together. Rate is decreasing or the rate is increasing. So interpret the meaning of the definite integral from 1 to 10 of C of t indicated by the units of measure. First off, what do you think the units are going to be? Just ounces, right? Anytime we do integral, we have to keep reminding ourselves that it's no longer ounces per minute. It's going to be, we're multiplying, right? Ounces per minute times minute is going to be minutes. It's like we understand that when we do C prime, our units are changing. So it should make sense that if we take the antiderivative, our units are also changing. I think that the tendency is we see that C of t there, and we want to talk about something in terms of ounces per minute, but it has changed. It's in terms of ounces here. So this is also kind of displacement related, because ultimately, I know we don't have uppercase C here, but we can say this. And this indicates to us how much has been added to the cup between the first and the 10th minute. Okay, that's what this means. It doesn't mean that this is the amount is in the cup. It just means, you know, whatever amount we started off 1 minute in, by the 10th minute, whatever's been added in that time period is our is what this represents. The change in the amount of coffee added to the cup between the first and the 10th minute in terms of ounces. Okay, part D, now I can use Riemann sums. Approximate using two middle rectangles. So we want to go from 0 to 3. Oh, sorry. We're going from 1 to 10, so we're not going to involve 0. So we'll go from 1 to 6, and then from 6 to 10. There's always going to be an overlapping interval using the same order pair. So we should need to find the width and the height. What's the width of my first interval? 5. I'm always subtracting. And then what height do I want to choose? 4.2. Good. And we're talking about ounces here, right? So this is approximating then that between the first and 10th minute, we're going to have this amount of coffee added to the cup. And if I want to talk about average rate of change, average water added, then that's average value theorem. I got to do that 1 over b minus a in front of my integral approximation. So this is yeah, it's a good question. This is average rate of water here. we know that this integral is gonna turn into ounces, right? But you know that this 1/10 - 1 is in terms of minutes. So it's gonna be ounces divided by minutes, so that's why we're back to ounces per minute. Is that 1/b minus a, it will change our unit back from where we got to. All right, your homework. Just two problems here, page 16 and 17. Differential equations. All right, go get your phones.
All right.
Okay, sure. Nathan. That last problem that you had questions about with the integral, I want to see how much points to give you. So if you want to come back and retry that problem with the knowledge of your interval, I want to, because you didn't finish the problem, so I don't know how much how much points to get. You want to come back and try that?
Yeah.
Well, I want to see this question. I want to hear it.
Okay, I can do tomorrow morning.
Okay, sounds good.
I was just curious. I just randomly got this like question. Was Calc a thing when you were in high school?
It wasn't offered at my school,
Okay.
but I think it's been around.
Yeah, and that.
Yeah.
Yeah. 25.
It's okay. I'm not back today, so well,
Yeah.
show up.
Oh, and then are you gonna come back with this? You think that? Okay.
You got it. Why?
No, you don't.
Why? Would you like to do this? Yeah.